morning, everyone. Yes, I not started, right? It said is not audible. They're on the queues. We'll explain the queues and the binary search and the remaining sorting technique also. Then I will assign the same questions on the practice sessions, practice questions. There are the drive of the DXC is at 15, right? Then nearly 1 week is to practice, right? And practice every day, and you can answer it for that. Okay. Then every day we are going to conduct some doubt session. We are going to plan for the next 4 to 5 days. Then we will intimate to you. Okay, guys. Yes. The drive is at 15, right? I think you got the mail, right? DXC drive is at 15 and 14. There is a pre-placement talk, I think. Yes, yes. I'm going to tell you the concept of queue. Then we can answer it very easily. Very easy topic that is also. If you don't know the concept, then only you cannot find it. That's it. Same like stack. This is also one data structure, linear data structure like this. And the size of the queue is going to be, 5. The size of the queue is going to be 5. Yes, I will explain. Just I'm today explaining that only. Okay. I'm going to give you the practice session, practice questions in the next 4 to 5 days. We're going to give you the practice sessions. The practice sessions, we are going to give you a very tricky question. Then you can answer it very easily. Okay. First of all, practice it. Then you will. Okay. Here, this is a queue. For example, this is a queue. This is queue. And here size is equal to 5. Then the index is going to be 0, 1, 2, 3, 4. Okay. For example, if you work with stack, there is only one element that is called a top, right? Top. And the stack, the operations is known as the last in, first out. The element which is inserted first, that is deleted last, right? That is last inserted is first out. Okay. Or else it is going to be first in, last out. Stack is going to be follow. Stack is going to be follow this rule. Last in, first out, or first in, last out. Okay, like queue is going to be first in, first out, or last in, last out. This is the formula. This is the way for queue here. First in, first out, which is inserted first, that is deleted first out. Last inserted is last out. Same as queue. For example, if you are working with any queue here, in general life also, who is in the line, he is going to take the ticket first, right? The same way here also, first in, first out, or last in, last out. Okay. The terminology what I'm talking here, each and everything is one single MCQ. Okay. And here, like a stack, there is only one element, and that is the top. We can delete and we can insert at the end of top only. But here there are two arguments. There are two arguments that are called front and rear. Both are initially at -1. 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 That indicates there is no elements in the queue. The same question that is going to be asked here also. I'll show you one question. Yes, in the queue implemented using linked list is done when the pointer is just observe here. when the element is entered into the empty queue. What is an empty queue here? Empty queue means both front and rear both are going to be at -1. If you want to insert an element into an empty queue, we have to update both front and rear. Not only the single point here, we have to update both front and rear pointer. And this is also working on queue here. I will explain the question. Okay. Now there are two functions again in the stack, that is a push and a pop, push for insertion, pop for deletion. Here that is called NQ and DQ. NQ for insertion, DQ for deletion. NQ for insertion, DQ for deletion. Okay. Now, for example, I am going to write here NQ of 10 for example. 10 for example. Now both are at -1. That indicates there is no elements, right? There is no elements here. There is no elements in the queue. Now I'm going to insert 10 here. That means I'm going to insert at this position. If both are at -1, I have to update both. And I have to put front and rear both are at this position. 0. Then I'm going to insert 10 at rear end. Okay, or front end. If it is a first element. Okay. If it is full, we cannot tell that. Okay, when it is full, I'm going to explain you. In the next time, again, I'm going to work with NQ of 20, for example. NQ of 20. I have to increment rear. Rear means that is the last point, right? That means here rear is going to be updated. And 20 is going to be inserted at a rear end. That means NQ is going to be done at a rear end. DQ is done at a front end. Who is at front? That is going to be take the ticket first and is moving from the queue. Clear, everyone? NQ, that means insertion. If there is new person is coming to take the ticket, he is going to be added as a last element in the queue. Okay. Anyone in the queue, he is going to be take the ticket. He is moving out of the queue. That is from the front end. Okay. If you know the language syntax, it is better to write both is same. If you are going for Python or C, both are same for data structures and algorithm. Okay. Not application. I think that is a mail. I think we got a mail. Got a mail from DXC. DXC is on 15. There is a 14. There is a pre-placement talk is there. The round is DXC is very simple. First of all, it is not typical. DXC is very simple. Okay. Then again, I'm going to insert NQ of 30 and rear is updated, and 30 is inserted at this position. Again, NQ of 40, rear is updated and 40 is inserted at this position. NQ of 50, rear is updated and 50 is inserted at the rear end. For example, NQ of 60, now where is the rear end? Where is the rear end? Rear is at size -1. If rear is equal to size -1, then indicates Q is full or overflow or overflow. Okay, it is full or overflow. For example, if both are at same place, for example, both are at -1, front is equal to -1 and rear is equal to -1. If both are at -1, that indicates the first element. We have to update both, not only the single element. I have to update both, right? Then front is equal to 0 and comma rear is equal to 0. Okay, and I have to update q of rear is equal to the value. Else, if both are at not -1, that means that is not the first element to insert. Just simply I'm going to insert rear plus plus and I'm going to insert q of rear is equal to value. Q of rear is equal to value. That's it. If both are at -1, I have to update both. I have to update both and I have to insert at rear end. Else that means that is not the first element. I have to increment rear end only and I have to insert it. That's it. Instead of writing all these things, we can write very easily also. Like this also we can write it. If front is equal to -1 and rear is equal to -1, both are at -1. I have to increment front only. Anything I have to increment always. I'm going to increment rear, and then rear is equal to -1. Sorry, rear is equal to value. And if it is at -1, both are at -1. I have to increment front only. Then rear is automatically incremented right here. With this automatically incremented, and every time I'm going to work with this value. I'm going to insert it. This is the logic for Q algorithm. Q for NQ. Okay, that is insertion algorithm. Whenever it is full, we have to when we are going to insert it, we have to check is it full or not. If it is full, the full condition is if rear is at size -1, we can tell that it is going to be a full. Both are at -1. That means there is no element here. We have to update both values. That's why I'm going to write front is equal to 0. Front is updated. Then rear is also updated and the value is inserted. If that is not the first value, this is not happened, right? These two only happen. Rear is plus plus and Q becomes like that. Okay. And for example, if I want to insert, I want to delete it. What is the empty condition? The empty condition is going to be both are at -1. If both are at -1, that indicates, for example, dq of both are at -1. That indicates rear is equal to -1 and front is equal to -1. Both at -1. That indicates there is no elements, right? We cannot delete it. Then we can simply tell that Q is empty or underflow. We can tell like this. Can intimate like this. For example, now it is going to be both are at single value. For example, here I will tell you there is one case here. For example, there is only one element. For example, there is a queue like this. There is only one element. That means both front and rear both are at the same place, and this is 0. I have to update both values to -1, not the single value. That's why I have to write, I have to check this condition also. And I have to check this condition also when I'm working here like this. If front is equal to rear, both are at same place, I have to increment, I have to done f is equal to -1 and is equal to -1 and rear is equal to -1. Both has to be -1. If it is not like that, for example, in this case, like this, if it is not like that, just simply I'm going to f plus plus, that's it, f plus plus. That means I'm going to delete this value and f is moving here, f is moving into this position, f is moving into this position. F is moving into this position. That means this is now the front element. I have to delete this one. Again, I'm going to deq it. F plus plus, again it is moving into this one. F plus plus, it is moving into this one. F plus plus, it is deleting into this one. For example, now F is at this place. And again, I'm going to apply. This is not there, this is not there, and this is not there. I'm going to apply again DQ. Both are at same place, right? F is equal to R. Then I'm going to delete this value and I have to update F is equal to -1 and R is equal to -1. That indicates there is no elements in the queue here. That's it. Clear, I think, everyone? This is the operation here. Now I'm going to work with what is the operation performed by the above function? What is this on the queue? Consider this function empty, okay. It is checking that is empty or not, if the queue is empty and there is a not symbol. If it is not empty, I'm going to delete one element. I have to delete one element and I have to call FQ here. Again, I'm going to call it FQ. I will explain you how it works, okay? So typical question, no doubt about that. This is the typical question. For example, there is one queue, for example. I'm going to take the queue at this position. What is happening? I will show you. 1, 2, 4, for example, like this. And this is 0. This is 0. This is 1. This is 2. This is 3, 4, and this is 5. Okay. Now both front is equal to understand this. I'm going to give some values here. Okay. This is 20 and this is 30. This is 40. Okay, I'm going to take like this. Okay, I'm going to take 3 values here like this. Now I'm going to check that is empty of queue. Is empty of queue. It is checking that is empty of queue returns true. If the queue is empty, false otherwise. Okay. If it is empty, then only it will return true here. But there is a not symbol is there here. There is a not symbol. That means it is checking that it is not an empty. It is not an empty. It is checking. Okay. And here we have to tell that what this operation is doing here. What this operation is doing. Is it empty the queue? Is it clear the queue? Reverse the order of the element of the queue. Delete the element at the front of the queue and it inserts rear, keeping the other elements at the same order. Leaves the queue unchanged. What is happening here? You don't know. Okay. And this is working with recursion also. If you observe here, it is working with recursion also. Okay. Now, this is I is equal to delete of queue. I is equal to delete of queue. It is working like this. If this is not empty, right? This is not an empty. Then it is going to be delete that I is equal to, first of all, the f of function is going to be calling like this. If the function is going to be called like this, and in the next element, it is going to be like this. I is equal to delete of q. And now if you observe here, front is at this position, rear is at this position. Okay. Now I is equal to at this position, I is equal to, if it is going to be delete, the value is going to be 10 here. Okay. Then again it is going to be called the same function fq again. That means it is deleted. What happened? 10 is deleted here, 10 is deleted here, and front is moving here. Front is moving here. Okay. Then again it is calling as a fun off. Then again it is calling as fun off. And is it empty? Is the queue is empty? No. Then again it is going to be work here. To copy this method. This is the first line, and this is the second line, and this is the third line. Okay, we are always at the second line only. We are not moving into the third line. Okay, if the third line is also completed, then only the function is finished. We already discussed in the recursion concept. Okay, just observe here. This is recursion. Again, it is calling. Okay, in the second function call. And now f is at like this, and I is equal to 20 now. I is equal to 20 now, and f is it is going to be deleted. 20 is going to be deleted, and f is moving into this position. F is moving into this position. Okay. Is it empty? No, it contains single element, right? It contains single element, and again it is working like this. F of. And in this function call, I is equal to 30 now. I is equal to 30 now. If it is 30, what will happen? It is going to be delete the both the values, and f and r becomes -1, right? F and r both becomes -1. There is no elements here. Then again it is going to be called f of, and it is telling that is it empty? Yes, it is empty now. Is it not empty? No, it is empty, right? That's why now this function is going to be finished. This working is finished here. That means for this function call, the line 2 is completed. The line 2 is completed. If the line 2 is completed, the line 2 is completed. If the line 2 is completed here, then the I value is going to be 30, and 30 is going to be inserted here. 30 is going to be inserted. If 30 is inserted, that means 30 is at this position. And this line is finished, then it is moving here, and a 20 is inserted, and then 10 is inserted. Before that, what are the values here? 20, 10, 20, 30, right? But now after this, what is happening here? It is reversing the queue here. It is reversing the queue. Then the answer is going to be reversing the order of the queue is the answer here. Reversing the order of the elements in the queue. Is it clear, everyone? Is it clear, everyone? Is it clear? Going to the next question. The same, right? Same question, I think. The same question, but a different approach. Same thing. Delete of queue, and the same question. This is also queue is reversed. That's it. Here, the question. In the queue is implemented using single linked list or array anything, and tracking is done with both front and rear pointers. Which pointer is updated when element is entered into an empty queue? If it is not an empty queue, only rear pointer is going to be incremented, right? If it is not an empty queue, only rear pointer is incremented. That is the answer. But it is an empty queue. We have to update both the pointers. Both the pointers we have to update. Is it clear? For example, the same question, the elements enter into the non-empty queue, for example. Then the answer is going to be only rear pointer, only rear pointer. If it is an empty queue, we already discussed about that, right? There is no elements, that means F and rear both are at -1. We have to update both and we have to take both values at this position only, right? Clear? And this is the answer for that. That is about Q. That is about Q. That's it. Do not understand the recursion is included here. That is the mistake. Okay. Here there is recursion is included. Again, I'm going to try to can I explain it again? How it is working? First of all, you know how the recursion is working, then only you can understand how it is working here. Can I explain it again? Yes. Okay. And I'm going to explain one more thing, that is going to be binary search. Binary search also I have to explain. And then I'm going to explain a recursion here. Today I'm going to I will available for the doubt session and I'm going to explain the recursive questions what are asked in the DXC and Capgemini. Okay. What is binary search? For example, the elements for binary search, definitely the array is going to be in a sorted order. Then only we can apply. Then only we can apply binary search. The first rule. We have to search an element in the using binary search technique. The array is going to be in a sorted order. Then only we can search it. Okay, for example, like this. It is going to be in a sorted order, right? That is going to be in a sorted order. The array is going to be in a sorted order, then only we can apply sort binary search here. Okay, the index are going to be this one. This. And for example, I'm going to search element is equal to, for example, 70. For example, I'm going for 60. Okay, I'm going to search the element is going to be 60. Is the 60 is in the list or not? Yes. For example, if you go for linear search algorithm, first of all, I have to take I at this position. Is 60 is equal to 10? No. Is 60 is equal to 20? No. Is 60 is equal to 30? No. Is 60 is equal to 50? No. Is 60 is equal to 60? Yes. And I'm going to tell that yes, 60 is in the list. This is it is checking all the elements and it is searching like that. The linear search. If you go for the binary search, it is taking two arguments here, that is L and H. L is at 0 and H is at last position. And I have to find what is the minimum element. L plus H by 2, that means 0 plus 6 by 2, that is going to be 3. At this position, that is going to be M. That is going to be M here. Now I am going to check that is 50 is equal to 60 or not. Is 50 is equal to 60? No. How many comparisons here? There is only one comparison here. I am going to search with one element. Okay. Is it, if it is true, I'm going to tell that yes, the element is found. Yes, the element is going to be found. But here it is not equal, right? And then I have to search for is 50 is greater than 60? Is 50 is greater than 60? For example, I'm going to search for 20. For example, I'm going to search for 20. Is 50 is greater than 20? Yes. That means there is no need to check 20 in this. Yes, the search element is smaller than middle element. Then I have to search the element in this list only. There is no need to check in this position, right? That's why I'm going to move this h to m minus 1. Then here it is going to be. If it is true, I have to update h is equal to middle minus 1. Then I'm coming here. For example, now the 50 is the middle element is less than 60. I'm going to find, for example, 60 here. I'm going to find the middle element. The 60 is greater than. There is no need to check these elements. There is search in this elements only. That means now I'm going to update here. I'm going to update here. L is equal to, that means the lower bound is equal to m plus 1 here. Clear? And now L is coming into this position. L is coming into this position. Okay. Now L is coming into this position. Now again I am going to find the middle element. L plus h by 2. That means 6 plus 4 by 2. 10. 10 by 2. That is going to be m. This is m now. Observe here. This is going to be m. Now I'm going to calculate how many comparisons I'm doing now. I'm going to do only the 2 comparisons, right? And then is the middle element, what is 77, right? The middle element is 77 now. Is 77 is equal to 60? No. Is 77 is less than 60? No. Is 77 is greater than 60? Yes. Then I have to modify h is equal to m minus 1. M minus 1. Then L and h both are at same place. Both are at same place, right? Then again I'm going to calculate L plus h. L is 4, h is 4. 4 plus 4 is 8. 8 by 2 is 4 only. That means now m also at this position. M also at this position. Now is 60 is equal to 60? Yes. Then in 3 comparisons we can find 60 here. This is binary search. This is binary search. Are you getting my point or not, students? Is it clear, everyone? How binary search is working? You didn't got any information about Kyndryl? Got only about DXC only. I think there is no registration and college management has to send who are eligible for the drive. Then you got the links to your mail, I think. Yes, this is about binary search and one question is on binary search, I think. There it is. The search begins the search with element that is located in the middle of the array. That is binary search. That is binary search. The search begins the search with the element that is located in the middle of the array. That is binary search. If you know the concept clearly, you can answer any question on the topic. You are not aware about, you can answer only that single question. Clear, everyone? For example, here also, which of the following searching techniques do not require the data to be in a sorted order? For binary search, the data is going to be in a sorted order, right? That means this is not true. Does not require the data in a sorted order. Does not require, okay? That means binary search required sorted order. That's why this is not correct answer. And this is not also correct answer. The linear search is the answer. For the linear search, the data is need not be in a sorted order. Need not be in a sorted order. Any value, it is checking from the first element to the last element, right? It is checking from first element to the last element. then there is no need to in the sorted order. There is no need of sorted order, right? That's why the answer is going to be linear search. Clear, everyone? The worst case of time complexity of the binary search matches with linear search. For example, the time required to search an element in a linked list, that is, we can search the elements in the linked list is in a linear order only. We cannot apply binary search on the linked list. That's why that's why definitely if you want to search, we have to go element by element. That means if there is no element in the list, that is the worst case. That is the worst case. That means I have to search all the elements, right? That's why I have to go for order of n. Order of n is the searching an element here in the linked list. For binary search, the log that is going to the time complexity is going to be order of log n, order of log n, order of log n. If it is going to be linear also, then linear that is going to be order of n. That means I have to check all the n values. The time complexity of the linear algorithm over an array, that is always order of n only, order of n only. What we have to think means if the element is not found or the element is the last element, we have to check all the elements, right? All the elements I have to check in the linear and the linked list. That's why it is going to be checked. That is going to be order of n here. Order of n is the time complexity. Clear, everyone? The last class we discussed about some sorting technique, I think. Selection sort and insertion sort, I think, right? And I'm going for bubble sort. And I'm going to work with bubble sort here. For example, these are the elements. Bubble sort. How I'm going to apply bubble sort here to the list? Every time, I think this is explained, right? Which functionality? We don't know. If they are going to be clear our doubts at DXC pre-placement talk only. Is it online or offline? Okay. The questions is repeat in the exam. That means questions are going to be repeat from the previous questions, or the, for example, for the same time the same questions for your friends. What is that? I'm not getting that. Definitely. Think I explained binary bubble sort, right? I think I'm not explained the insertion sort and what I have not explained in the first three sorting. I think I explained right all the three: selection, insertion, and bubble. These three is enough for the sorting techniques and the MCQs, especially MCQs. All the MCQs are going to be from these three only, on the three basic sorting techniques only. Not getting your question. I will explain yesterday's pseudocode questions. The doubt session I will explain. Okay. Today 8:30 to 9:30 I'm going to take, and I'm going to explain the recursion concept, and I'm going to explain the pseudocode questions. Questions are very tricky. Yes, I will explain. Okay. Once I explain the selection sort. Selection sort, for example, here in the selection sort, we have to select either maximum or minimum, whatever you want. We have to find what is the maximum element here in the unsorted list. What is the maximum element? That is 45, right? We had to swap 45 with the last element. That's it. The maximum element is 45, and I have to swap with the last element. Then this is sorted, and in this, what is the maximum element here? What is the maximum element? The maximum element is 30, and I have to swap with the unsorted last element. That means 30 and 12 are going to be swapped here. 30 and 12 are going to be swapped here. And these two elements are swapped, sorted. These two elements are sorted. Now within this, what is the maximum element? That is 20. And I have to swap 20 and 5. The easiest sorting technique is selection only. Now I am going to swap this 5 and 20. And now here, what is the maximum element? The maximum element is 12. 12 is replaced with the 12 only. Okay. Then going with these two, what is the maximum element? 10. 10 is swapped with the 10 only. And I had to stop here. And this is the selection sort. We have to select the maximum value and we have to replace with the last element. That's it. Please don't think about the next drives. The drive is live, the DXC is the date is released, right? Just think about DXC. Don't think about what is IBM, when the Capgemini is coming. Don't think all these things. First of all, think about only one thing, that is DXC. We are not going to give you the date of IBM or Capgemini. We don't know exactly, right? We know exactly only one date. After all the completion of the DXC selection process, then in the third week or fourth week, there maybe we don't know exactly, right? Sunday grant tests are locked till the night. Yes, I didn't wrote the test. And what about the tester? Just leave it. We are assigning at that time only, right? You have to write at that time when you are working with that. Yes, first drive is DXC only. No coding round, yeah. No coding round. I think this is the first class for you. I think that's why you are asking the question. Yes. Chaitanya sir.
Yes, sir.
Yes, sir.
Good morning, Andy. Sir, voice when is noise. My voice audible, sir?
Yes, sir. Yes, sir. But a little bit low, sir.
Okay, sir. Okay. So I'll try to speak a bit louder. Okay. Good morning, students. So please let me know one thing. Is it clear from my side or not? If there is any problem in my voice, please let me know immediately. Okay, audible. So Sar has left. The time has finished. He has to come to college at 9:30. So he's going to start from his house. So he left the meeting just now. So if you have any questions regarding this technical or maybe any coding related questions, so maybe Sar will join again at 12 o'clock, or maybe he said, so he will clear your doubts by taking the class of today evening. Okay. Yeah. So for confirming me that it is clear and no problem at all. Okay. So let me share my screen and we'll discuss some that means the questions of DXC test 7 what you have written yesterday. So I have shared my screen. Hope it is visible to all of you now. Is there, your voice is too low, sir? Uh, so I'm very close to the laptop and I'm speaking a bit louder, but still, if the voice is low, I don't know what's the problem is. Maybe the network issue. I think. Uh, so I'll try my best to speak more louder and louder. Okay. So let's start the text explanation of DXC test 7. The first question, which is from number series. So see the series here 9, 3, 30, 18, 6, 36 and 12. Okay. So just by seeing this, I told you whenever the series is increasing and decreasing or decreasing and increasing alternatively. So we have to check the alternate digits in the series or alternate numbers in the series. If you take the numbers 9, 18 and 36 and also 3, 6 and 12, these three digits and these three numbers and the remaining three numbers are related to each other in a particular manner. Is 3 into 2 and 6 into 2. Here also 9 into 2 and 18 into 2. So I have to find the next number after 36. So I have to multiply with 2. So the answer should be 72 here. Okay. So the answer is 72. So that's a simple alternate series. So I have to consider the alternate numbers in the series because they are following a logic called into 2. Okay. So I hope it is clear for everyone because that was a very, very easy question. Someone said it is 48. It is not 48. It is 72. Okay. It is simply 9 into 2, 18 into 2 and 36 into 2. Okay. We'll move on to the next question from analogy. So the first given pair of letters are DEF and EDF. So if you observe the same letters are present in both of these, but just there is a change in order of the first two letters. F is common, that is in the third place, but the first two letters are interchanged. Okay, they change their positions. That's it. By applying the same logic, so I have to find it for GHI. Okay, so I have to keep the last letter same and I have to interchange the positions of first two letters. So then I'll get HGI. Okay, that is a simple interchanging or changing the positions of the letters. Okay, so when I see the same letters are there, so that's why the logic is simple, changing the order of the letters. Very good. HGI is the answer. Okay. So moving on to the next one, next question from analogy. So the first given two words are invite. Okay. So invite is related to J O W J U F. Okay. So if you clearly observe these letters here, J is the next letter of I, O is the next letter of N, W is the next letter of V, and J is the next letter of I, T, U is the next letter of T, and F is the next letter of E. So simply they are coding each and every letter with its next letter. That is what the relation between the first two. In the same way, I have to write it for attend. Okay, the next letter of A is B. The next letter for T is U here. E is F, N is O, and D is E. Okay, so U F O E. So that is the answer. The first two option. So BUUFOE. So it's a simple, the each and every letter is related to the next letter. Okay, is written as the next letter in the alphabet. Okay. Yeah, even for the next question, I got answers from some of the students saying that BOUFOE. That is very simple question. So let's move on to the another topic, odd man out. So let's see what is the odd one among the given four options. And we know that generally we follow three rules. One is the gap rule. So A, D, G. Okay. So between A and D, I have two letters, that is B, C. And between D and G, I again have two letters like E and F. Okay. And coming to H, K, N. So H is 8 and K is 11 and N is 14. So in between H and K, I have two letters called I and J. And in between K and N, I have two letters called L and M. Okay. And coming to PSW, P is 16 and S is 19. So between P and S, I have two letters called Q and R. And between S and W, I have three letters like T, U, V. Okay. So T, U, V are the three letters between S and W. But coming to MPS, so in between M and P, I have two letters N and O. And in between P and S, I have two letters Q and R. Okay. So for every option except the third one, the difference between the letters is 2. That means the number of letters in between those letters are 2. But coming to this PSW, that is not following there. So which was followed by the remaining 3. The option 3 is not following that similar logic. So I can say PSW is the odd one among the 4. Yes, even for this also I got response from few students, but one said ADG is the option, but ADG is not the option correct one. Okay, it's not the correct option. But still I'm getting only answer from 15 to 20 students only. So I request even the remaining students, because 500 plus students are there, please respond actively. So give your answer, check how fast you are doing it. Okay, so are you getting the answer right or not? Along with you, how many people are getting right? Okay, so all these things you have to consider, right? Next one is odd one out among the given. PQR, so the three consecutive letters. ABC, three consecutive letters. TUV, three consecutive letters. But QSR is not in the alphabetical order. So it is Q, R and S. Okay, so PQRST, but here it is absolutely in the correct order, TUV, ABC and PQR. So one more easiest one we have. So the simplest of all the questions from odd one out like this. So three consecutive letters and the option D is not consecutive. Okay, they are not following the order. So that is the simple question we have. So QSR, very good. Okay. So moving on to the next question, that is from coding and decoding here. So forward is coded as DRAMROF. Okay. So if you observe this clearly, so forward, so what I have written DRA. So that is nothing but DRA. So they started from the back side. So DRA and ROF here. So again ROF. So DRA ROF. Here instead of W, they used M. Okay. So W is 23rd and M is 13. Okay. Can I say 23 minus 10 or something else, or else? So they just flipped the W and they written as M. Okay. Upside down. So they made it upside down and they have written M. So that is why they have written M. So the middle letter, so they made it upside down. Okay. And all the remaining they have written in the reverse order starting from the back side. So I'll apply the same thing for reverse, which is also a 7-letter word. Okay. So 7-letter word. The first 3 letters I have to write here, that is ESR, and the next 3 letters like VER I have to write here, and I have to upside down the E. So even if I make the upside down E, it will be like this only. There won't be any change in the E. Okay, even I flip it, so it will appear like E only. Okay, but when I flip W, it will appear as M. Okay, so the answer should be ESR, EVER. Okay, so the only thing is, so the middle letter, instead of keeping the same, they flipped it, and everything they written in the reverse order. Okay, it should be option A. Yes, is option A. Very good. ESR, EVER. Good. Next, it's a logical sequence of order. That is an easy one, I think, based on the size. Okay. Uh, the words are Taj Mahal, India, Asia, Agra, and Uttar Pradesh. Okay, so among all these, if I go from smallest to the largest or from largest to smallest, I'll arrange them. For example, first one is Taj Mahal. Okay, so Taj Mahal is only one place or one building or one tomb it is. Okay, so Taj Mahal will be in Agra. Agra is a city. Okay, so that city is in Uttar Pradesh, that is a state. Okay, so and next Uttar Pradesh is in India, so which is a country, and India is in Asia, which is a continent. Okay, so it's a place, city, state, country, and continent. So that should be the correct order. I know Taj Mahal is first word, Agra is the fourth word, Uttar Pradesh is fifth one, India is second one, and Asia is the third one. So 1, 4, 5, 2, 3. That is one order. So when I arrange it from smallest to the largest, or if it from largest to the smallest, the order should be 3, 2, 5, 4, 1. So which is in the options here? So we have 1, 4, 5, 2, 3 is not there, but 3, 2, 5, 4, 5. That is in the option D here. Okay, so that means they have arranged from the biggest to the smallest. That means continent, country, state, city, and place. Okay, so it is 3, 2, 5, 4, 1. Very good. 3, 2, 5, 4, 1, option D. But someone given it as 1, 4, 2, 5, 3. That is not correct. Option A is not correct. Okay, so it is 3, 2, 5, 4, 1. Option D is the only answer. Option D is also not answer. So in the given options, we have only option D as correct. So we don't have any other option as correct one. Because see, the correct order is 1, 4, 5, 2, 3. 1, 4, 5, 2, 3 option is nowhere in the given options. The only thing is, so we have to do it in the reverse way. That means starting from the biggest to the smallest, 3, 2, 5, 4, 1. Okay, so that is the correct order. So I think it is clear. Moving on to the next question from directions. Yesterday we have done this. So 12 feet towards east and 4 feet towards south. So that means 12 feet towards east, and from then 4 feet towards south, and again 9 feet towards west here. Okay. So now what is the distance between initial position? So I want to find this distance, and this distance is 4, and this distance will be 3, because 12 minus 9 it is 3. So I want to find this distance here. What is this distance? So hypotenuse square is equal to, so 3 square plus 4 square, that is equal to 25. So that h is equal to, or hypotenuse is equal to 5 feet. Okay, so yesterday we did this. We explained the same question in the yesterday session. Yeah, that is 5 feet. Very good. So moving on to the next one. Yeah, a baby crawls 8 feet towards west. For example, if I take the position of the baby, first the baby travels 8 feet towards west. Okay, and then 8 feet towards north, and from then, so the baby travel 8 feet towards north. Okay, and then it moves 14 feet towards east. So from then towards east 14 feet. So this is 14, and now the baby is there. How far and which direction is the baby from the starting point here? So this is the final position of the baby and this is the initial position or starting point. I have to find the distance between these 2 points here. This is what I have to find. So try to make it as a right angle triangle by drawing a straight line from the initial point to the direction. So what I'll get, what is the height of this triangle now? This height is equal to 8 because these two are equal. So that is equal to 8. And what will be this distance? The entire is 14 and from here to here it is 8. So 8 minus 6, then this will be equal to 6. Now hypotenuse square will be equal to 6 square plus 8 square. So which is 36 plus 64. That is equal to 100. That means hypotenuse value is equal to 10 feet. Okay. So that means this value is equal to 10 feet. The distance between the starting point and the ending point of the baby is 10 feet. Okay. So 10 feet towards which direction? Okay. So this is the starting point and this is the ending point. So when I watch it from the starting point, so the baby is in this direction. So what is that direction? So we know this is east and this is north. In between north and east, it will be northeast direction. So 10 feet towards northeast direction. Okay. So it is very simple one, 10 feet towards northeast. Very good. So option B, 10 feet towards northeast. Very good. So some students, they have written the entire answer. That is very appreciable instead of giving option B. Okay. So that's fine. Whether they give option B or they have written 10 feet towards northeast, both are correct. Okay. But still expecting many students to give the response. I'm getting only from 15 to 20, not more than that. Okay. Next one, P is the daughter of Q. So a simple statement from blood relations. P is the daughter of Q. Q is there and Q's daughter is P. Since daughter, I'll represent with a minus. R is the brother of P, brother that belongs to the same generation, R. So since R is the brother, I'll represent with a positive symbol. S is the father of R. So S is the father of R means S is the father of both P and R. So if S is the father, then I can say S and Q are the couple, where S is the father means Q will be the mother. Okay. Now how is Q related to S? So how is Q related to S? Q is the wife of S. Okay. So Q is the wife of S. I hope this question was discussed in yesterday's doubt session. So if not wrong, the same question we discussed in yesterday. Okay. So that is wife. Okay. So simple, try to draw the diagram, then it will be very easy for you to answer these questions. P is the daughter of Q and R is the brother of P. S is the father of R means we already know P and R are the children of Q. Now S is the father of them means S is their father means obviously Q is their mother. Now how is Q related to S means Q is the wife of S. Okay. And next, coming to another question, B is the only child of A. So here it is A, their only child is B. M1 and are the children of B. So B has two child, that is M, sorry. So B has two child, that is M and N. So M1 and are the children of B. D is the grandmother of N. Okay, so grandmother means parent mother. Okay, I know M1 and parent is B and their mother is D. Okay, mother is D means already A is their grandparent. If grandmother is D, A. Now, how is A related to D? So, what is the relation of A and D? So, A and D are couples where A is the husband of D. Okay, so where A is the husband of D. How much tough is DXC exam? See, the questions what you are taking in the test are the questions given in the DXC last year. Okay, so you expect the same level of questions even in the coming exam also. The DXC exam, especially when it comes to the quantum reasoning part, they are going to be like easy to moderate. Okay, So 70% of the questions are easy and maybe 30% of the questions will be moderate level. Okay, so I didn't see till now a tough question from DXC. Okay, so not even one question is tough one. Okay, so if you know the basics of any concept, you can answer all the questions of DXC. Okay, moving on to the next one from coded inequalities. So what it is, they define different symbols like plus, minus, equal to, asterisk and slash. Okay, so let's take the statements here. It is m minus n. So minus means greater than. Okay, m greater than n is the first statement. Second one, n minus o, that is n greater than o, and o slash b, that means o equal to b. Okay, so if I combine these three statements, I will get it as m greater than n greater than o equal to p. So this is what the information we have from the given three statements. Okay, now, so what is the first conclusion? O minus m. So O minus m means, so it is actually O greater than m. Okay, so O greater than m. Is it correct? Is it O greater than m here? See, if you observe, m is greater than O and O is less than m. It is not greater than O. Sorry, it is not greater than m. So O is less than m. That is what the relation we have. So, but they said O is greater than m, which is a wrong conclusion. Okay, the first one is a wrong conclusion. Coming to the second one, so P greater than n. Okay, P minus n means P greater than n. So here also P is equal to O and it is less than n. That means P is less than n but not greater than n. Okay, so P greater than n is also a wrong conclusion. Okay, so we cannot say that any of the conclusion given are correct. So we have to go with option neither conclusion 1 nor 2 is true. Okay, so according to the given statements, none of these conclusion is true. Okay, so that's why I go with neither conclusion 1 nor 2 is true. A, neither 1 nor 2. Very good. Option C. Very good. Neither. Both are false. Good. Okay. So coming to this coded inequalities, generally the response from the students are limited. Okay. So even I have been observing from the past 2 or 3 days. So the number of students who are responding for these type of questions are reduced compared to the remaining questions. Okay. Let's see a question from a seating arrangement. Okay. Mallika, Maneni, Pallavi, Nikita, and Suhana are seated in a conference hall. Conference hall. This is E, not A. Conference hall facing the stage, which is in the north. Okay. Stage is placed on the north. Okay. This is, for example, this is the stage. So which is in the north side. They are facing the stage means those 5 persons are sitting by facing the stage. They are sitting in this way. Okay. They do not occupy any adjacent seats. So that means there are not only 5 seats, so many seats are there. So like this, so many are there, but they are not allowed to sit adjacent to each other. Okay, so they are not allowed to sit adjacent to each other means there should be at least one empty space between each of them. Okay, so many seats are there in the conference hall. They are facing the stage and they should not occupy the adjacent seats. Nobody has to sit adjacent to another person among these 5. Okay, so what is given? The seating arrangement is as given below. Maneni is seated 10 seats away to the right of Suhana. For example, here it is Suhana means to the right side because this is the right hand side. They are facing the north. So 10 seats away. So 10 seats away means like this. So from then the 10th seat is from for Maneni here. Okay. So this is 9 seats in between him, in between them, right? Pallavi is seated 20 seats away to the left of Nikita. So here, if it is Nikita here, to the left of Nikita, 20 seats away. So Pallavi is there. There may be 19 seats in between them. So Mallika is seated 30 seats in front of Suhana. So Suhana is seated here and Mallika is seated 30 seats. That means 29 seats. And here it is Mallika here. Okay. And Nikita is seated 15 seats to the right of Suhana. So this is the right side of Suhana. So where Mallika is seated there. Sorry, Nikita. So Nikita is seated, that is 4 seats in between Maneni and Nikita here. Now choose the correct answer. Who among us the following is seated to the left of Suhana? Okay. So I want to find the person who is sitting to the left of Suhana here. Okay. See, Suhana and Mallika. Mallika is in front of Suhana, not to the left of Suhana. Okay. And also Maneni and Nikita are also to the right hand side of Suhana. So they are not left. So Mallika is not my answer. Maneni is not my answer. Nikita is not my answer. Okay. So if among the 5, I'm asking to who is on to the left of Suhana, and I got 3 I eliminated 3, and the remaining option is obviously Pallavi here. See, this is the place of Nikita, and from there the Pallavi is sitting 19 places away or 20 places away. So that is why definitely to the left of Suhana I will get Pallavi here. Okay. Yeah, Pallavi is the answer. Many of them answered correct because except Pallavi, it is clearly given in the question. So Mallika is in front of Suhana and Maneni and Nikita are to the right side of Suhana. The only person remaining is Pallavi there. Okay. So if you read the question once before trying to arrange it, then you can answer it question directly without drawing anything here. Okay. So because I'm just now reading it, so I thought of drawing all these and I thought they were required. Actually, they are not required. Just by reading the question itself, you can answer who is to the left of Suhana then. Okay. So going to the next question from data sufficiency, the problem question is what is the area of the top of the table? So I want to find the area of the top of the table here. Okay. Now, the first statement, take the first statement alone. The top of the table is rectangular in shape. Okay, I understand the top of the table is rectangular in shape. Okay, just by knowing that it's a rectangular shape top, can I find the area for this without knowing the measurements of this rectangle? We cannot find. So that means statement 1 alone is not sufficient. Now take the statement 2 alone. The length of the top of the table is 35 centimeters. They're given the length of the top of the table is 35 centimeters. So just by knowing the length of the table, can I say what the area of the table without knowing it as a square or not, or maybe whether it is a rectangular shape or not? Okay, I cannot answer the question. That means even when I take the statement 2 alone, I just know the length of the table, but I don't know whether it is a square or a rectangle. So that is why I cannot find the area of the table here. Now take the statement 1 and statement 2 together. I know it's a rectangular shape table, and so the length of the table is 35 centimeters. Can I find the area now without knowing the breadth of the table here? No. So since I don't know the breadth of the table, now even by taking both the statements together, I cannot find the area of the table because area of the table is L into B. I know value of L, but I don't know the value of B. So I cannot find the value of the area. So even after both statements put together, so I cannot find the answer. So it should be option D there. Okay. Statement 1 alone is sufficient. How can it be sufficient? Just by knowing that that it is a rectangular table, can I find the area of the table here? Area of the table doesn't mean that L into B. Okay, I should say whether it is 100 square meters or 100 square centimeter or 50 square centimeter or something else. Okay, so and next Go, yes, option D, many of the statements given that. Very good. Okay. Moving on to that next slide, it was finished. So that's all about the questions that we have to be discussed in the yesterday's test. Okay. So hope every one of you have got some idea about all the topics we have been discussing from the past 15 days or 14 or maybe at least 2 weeks. Okay. So please try to practice more number of questions, as many you can, then only you can solve these questions in time and you can score maximum marks and improve the chances of getting selected for the next round. Okay, as I told you yesterday, when you have one offer in your hand, so obviously your confidence levels will be different and you will try or you will look this world in a different way. Okay, so when there is something in your hand, then definitely your perspective towards your life will change. You won't fear of anything. Okay, you will be relaxed and you can face anything with more confidence because you already have an offer. And if you try for any other thing, you will have that confidence. Even though I perform, if I don't perform well, I already have a offer. So that's why no need to feel pressure or tension, so I can perform with ease. So that is the confidence level you will have once you have an offer. So that's why try to crack this with that knowledge you have. Okay, that is more than sufficient to crack this DXC. What we are discussing is, so just because of that silence, I have muted myself. Uh, that's thank you everyone. Thank you so much. So if you don't have any doubts, you can leave and have your breakfast and get ready for the class at 10:15. So I don't think there will be a sectional cutoff for DXC. Even though they consider as a sectional wise, we cannot do anything because so completely it is in the hands of the company recruiters. Okay. So but it's better to score the minimum marks in each and every section. So then you can eliminate that problem of getting rejected because of not sufficient sectional marks or not reaching the sectional cutoff. Okay, so make sure that at least you answer 70% of the questions in each section. Okay, thank you so much. So I would like to thank each and every person who actively participated and gave the response in the chat box and made me to explain with more energy and something. Okay, so thank you everyone for your responses. I hope you have learned something in these classes and you will definitely try your best to clear the DXC test and crack the interview. Okay, all the very best. Be confident when you are facing the interview. Okay, so don't bother about the result and don't bother about which answer I have to give for this question, whether they will select me or not if I give this answer. All these don't put in your mind. Okay, so just make yourself free while attending an interview and try to present yourself in a beautiful manner so that the others get impressed by seeing you or the way you're talking or way that you are responding to the questions, the way you are looking at the problem and everything. Okay, so I don't want to waste much of your time. Okay, so thank you very much. You can leave the session for today. So that's the end of it.